Good morning, everyone. I'm Amma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to compare the various communication techniques, that is AM, FM, and PM. In amplitude modulation, where the modulation in which the amplitude of the carrier wave is varied in accordance with the amplitude of the modulating signal, where the message signal is shown in the first graph and the carrier signal, and followed by that the message and the carrier signal uh, is multiplied and shown here, where AM is a amplitude modulation, that is message signal, AC is a carrier signal, that is carrier amplitude, message amplitude, and we are adding that carrier amplitude and the message amplitude. Then the next one is frequency modulation. Here the modulation in which the frequency of the carrier wave is varied in accordance with some amplitude of the modulating signal. Here the amplitude of the carrier signal is constant. Amplitude of the carrier signal is constant. Only the frequency is varied in accordance with the message signal. That is, during the increase of the signal, the wave is constant, but while decreasing, the frequency is being varied as shown in the graph. Next one is a phase modulation. Modulation in which the phase of the carrier wave is varied in accordance with the amplitude of the modulating signal. The amplitude of the carrier signal is also constant here, where in the first figure shows the amplitude of the message signal. As usual, the carrier signal, the amplitude is getting constant, whereas uh, in the phase modulated wave, where we'll be having a carrier stretching and a carrier compression. During the decrease of the carrier stretching takes place, but in the increase of the signal, where the carrier compression takes place, that is phase lag and a phase lead takes place in the phase modulation. This is the various differences between the amplitude modulation, frequency modulation, um, where the modulating difference is nothing but in amplitude modulation, a radio wave known as the carrier is modulated in amplitude by the signal that is being transmitted, where in a frequency modulated, the frequency is being modulated, and the various parameters are the frequency and the phase remains same in the amplitude modulated wave, whereas in frequency modulated the amplitude and the phase remains same. The quality, where the amplitude modulation has a poorer sound quality because of a lower bandwidth, but it is cheaper. It can be transmitted over long distances as it has a lower bandwidth. Where FM is less affected by interference, but FM signals are impacted by the physical barriers. They have a better sound quality due to the higher bandwidth. Then the bandwidth of the AM is to FM, whereas in FM is nothing but a 2 into del plus FM, where we'll be having a wide channel is required here. Then the various sidebands are here, the number of sidebands is constant and equal to 2, but whereas here the number of sidebands having significant amplitude depends upon the modulation index, where the zero crossings in modulating signal, here it is equidistant and here it is not equidistant. The frequency required for broadcasting are, it requires 30 kilohertz, where here it requires 180 kilohertz. The complexity are, the AM transmitter and the receivers are less complex than FM and PM, whereas here FM AM, because of a variation of a modulating signal, it has been converted and detected from the corresponding variations in the frequencies. Then the difference between the phase is also displayed here, where the noise immunity of a FM is superior to AM and FM, but in FM the AM receivers are very susceptible to noise. Noise immunity is better than AM, but not in FM. So the main functions are the frequency of the carrier wave deviates here in the frequency modulation, whereas in amplitude, the amplitude of the carrier wave is varied. Then in the phase of the carrier wave varies as per the voltage. The various types of FMR digital FM, which having frequency shift keying and offset and a phase shift keying. In AM, we'll be having a double sideband, single sideband, and the vestigial sideband. In phase modulation, we'll be having a quadrature phase shift keying, binary shift keying, and a quadrature amplitude modulation. The assessment are displayed here with where mention the frequencies required for broadcasting and the various types of modulation. Thank you.